All right, this is AP Calculus, lesson 7-5. We're talking about speed and distance. So here's the setup. So we have this graph, and we need to analyze what's happening at each of these times. So velocity and acceleration. And we can make this note in green just somewhere above the graph. So velocity and acceleration. Velocity, is that height? Is that slope? Is that concavity? What is velocity?
Slope?
On this graph. Careful.
Height.
It's going to be height. GHT. And acceleration, what is that going to be? Someone aside from Sophia.
Slope.
Slope, perfect. So, when I look at my time at A, is the velocity positive or negative?
Positive.
Positive. So I'm going to say it's going to be greater than 0. Okay, acceleration, is it going to be positive or negative?
Positive.
Positive also. The slope here is positive. The slope is going up. All right. At B, at this point right here, velocity, positive or negative?
Positive.
Positive. Acceleration is?
Negative.
Negative. Yeah, the slope is going down. All right, what about at C down here?
Negative.
Negative and?
Negative.
And negative. Perfect. What about at D?
Equals 0 or D and E?
Equals 0? Well, I guess it could be an endpoint, so that is smart of you, Sophia. Maybe I should have had the graph continue on so that didn't happen. So I'm going to go like this so that didn't happen. So it's going to be equal to 0, and then what about acceleration?
0. Greater than 0?
Yeah, greater than 0. It's going to be positive. It's the positive slope here. So those are the slopes. Should be like this. Perfect. All right, so the main thing that we took away, we already saw this on a previous homework, but what does speed mean? So speed is, close, yeah, but it's specific to the absolute value of velocity. So think of this as, we'll do absolute value of velocity like this. You took away the component in terms of the direction. You're only talking about how fast you're going. I used to say for velocity that I'm going 3 miles per hour north. Now if I'm just talking about speed, I'm going 3 miles per hour. All right, so, and this is the important part. Speed is increasing when what? Do we remember from the other homework?
You go faster.
When you're going faster, I guess. It's not when you're going right. It has to do with this chart. When velocity and acceleration.
Position change.
Not exactly.
Oh, are
Are they right?
equal? Are both have the same sign?
Same sign, yeah. So
I
when
couldn't get the word down.
when velocity, I'm just going to write V and A to make this quicker. When velocity and acceleration, same sign. Speed is decreasing when velocity and acceleration,
Have opposite.
opposite sign. Let's analyze the graph here. So at A, I'm going faster and faster. Like I'm going a positive speed, and I'm going faster and faster because I have a positive slope. So I'm increasing here. At B, I'm decreasing in my speed because I'm already going positive in terms of my velocity, but I'm trying to slow down to go back to 0 velocity. So I'm slowing down at B. And the rest of that is still, I guess everything makes sense up until D. So what's happening at D? Am I speeding up or am I slowing down?
No, slowing down. No. Wait, for velocity? You're speeding up because if technically, you're speeding up.
Because you have a positive move.
Here, I would
Decreasing.
I would say it's neither because we don't really have a sign for 0.
That's hard. Cause like, yeah.
It's a philosophical question, right?
Yeah.
They're not. The AP test won't actually do this
If it
too.
equals, but if it was like the opposite, where say it was going down, like the acceleration was decreasing, don't you think it would be slowing down because it equals 0? Like if you start from rest and then you increase, you're. Oh, that is true. And then you start from rest and decrease, you're not.
Okay, so there's an
Yeah.
argument to be made for saying that at D you are increasing in speed.
It makes sense, honestly.
Yeah.
Like if you think about it that way, that doesn't. Because if it had been going the opposite way. Like if it was in between, if the point was in between B and C, you see where, like that would be decreasing. Like that, yeah.
Okay, yeah. So they're not going to ask that question to my knowledge. You just need to know these definitions when they're opposites and when they're the same sign. So we only need positive and negative. So let's go to the next slide. Everything's copied down here, yes?
Yeah.
Thumbs up. So this is our last slide. Do give yourself a number line that you can talk about for this graph. All right, so we're given a graph of velocity. So I did label that this is velocity with respect to time. So let's review. What is total position change again in terms of an equation?
Isn't it? Wait. Like
So in order to get-
over something?
So be careful. In order to get
Oh,
to
so
position
position
from velocity,
change.
Oh, you have to take the antiderivative.
the antiderivative, yeah, the integral, and then from whatever bounds we were talking about. So if I was talking about the total position change between, let's just say 0 and 5 seconds, this would be the integral between 0 and 5 of our velocity, vt dt. And we can actually calculate what that is. I'm going to give us some faux numbers in here. So I'm going to say that the area under the curve between 0 and 1, let's just say that that's 8. Area here, let's call that 4. And the area to the 5, that's going to be 8.
8 and 8 are equal.
I know, they don't really look equal, but I'm just making for simplicity.
Wait, that's given, or did you like find that out?
That's not, I mean, I'm giving it to you. It's a fake problem,
Okay.
but it's just for our notes.
This is not to scale.
Not to scale, sure. All right, so the total position change, and by the way, this 4 should really be a negative 4, right?
Yeah.
So the total position change is what? What numbers do we add together? We just add,
8, 4, and 8.
yeah, so what is the total position change then between 0 and 5 seconds?
12.
Should be 12. And the way that you get 12 is by doing 8 plus negative 4 plus 8, and you get 12. That is the total position change. But that is different from the total distance traveled.
That was different.
So just like in the last graph where we did the absolute value of velocity of time, what happens when I integrate the absolute value of time? And that's really the answer here. The total distance traveled, let's think about this before I give us the definition here, is from 2, I go forward 8. That's what this is saying. For 1 second, I go forward 8. So let's jump 8 places. So we go 1, 2, 3, 4, 5, 6, 7, 8. And now I'm at position what at 1 second?
Position 1. 10?
Yeah,
And then it's 1.
that's time equals 1 at position 10.
I'm confused. How did you get...
So I went 8. 8 is the total position change between 0 and 1 second. So this was time equals 0. And then at time equals 1, I'm now at 10 because it's the start plus the change. The change was 8.
Oh, okay.
And now let's talk about this interval here. How do I get to 2 seconds? Well, now I go back 4, right? So now I'm going to go back 1, 2, 3, 4. And now what position am I at time equals 2? 6. And then to get to time equals 5, I need to go forward a change of 8. So I go 1, 2, 3, 4, 5, 6, 7, 8. And I'm at position. Wait.
Uh-oh.
Something is wrong. We did our math wrong. Because I just got 14 at time equals 5. That's because we did our math wrong. This should have been 14. Math is hard.
Wait, 8 plus 4 is 12.
What's going on then? That's right, yeah. What's our error?
Maybe
8
it's...
plus 8 is 16 minus 4. We have that 2 in there from the beginning.
Oh yeah, we randomly had a plus 2.
Oh.
So the total position change is 12, so that's still right.
That's why
Yeah,
I'm
so the total
confused.
position change between 2 and 14, our total position change is still 12.
Oh, that is. Wait,
All right.
but how did you get t equals 5? Like, shouldn't that be t equals 3?
So look at 5, we go from 2 to 5,
so we
that
just
distance is 8.
Skipped over a few seconds.
We skipped over a few seconds, exactly.
Wait, so why is it 14?
So 14 because we had an initial condition of 2.
So
But the total position change from 2 to 14 is still 12, so there's not an error on here.
Okay.
Okay, but now I want to talk about the total distance traveled. Because I went forward and backward, this still counts towards our total distance traveled. So how far is our total distance traveled?
The absolute value.
Exactly. So what is the answer, though?
12? 16.
It's going to be more than 16 because I went forward 8, and then I go another 4, so that's... Oh, wait, maybe
It'll be 20.
I think you're right. Sorry.
Point.
No, you're still wrong. I'm sorry. I'm all over the place today. 8, and I went backwards 4, so I go up to 12, and then I go forward another 8. 12 plus 8 is...
Oh,
20.
So I have a total distance of 20. All of the bumps add up to 20. The total distance traveled
So
should
it's
add up to 20.
2 plus 8 plus 4 plus 8. Okay.
So this should be 20. How do I get that? The way that I do that is by taking the integral between 0 and 5 of velocity with respect to time of dt, but I take the absolute value of velocity of time. What that's essentially doing is it's bouncing everything that hits the x-axis, it's now positive. Instead of a -4, treat this as a +4. There are no more negatives now that I'm taking the absolute value. So this is turning it into 8 plus a +4 now, plus an 8 to get to 20. All you have to do to go from position change to total distance traveled is add the absolute value sign. I want to show you graphically what that looks like also.
wait, I don't know.
You don't have to write this down. I just want to have a demonstration. So this is an actual function. I took, what was the function? Natural log of x squared minus 3x plus 3, the one that we've been dealing with for a while. And look what happens. This is the total area. If I added all these up, I would have this negative in there. But if I took the absolute value, if I took g of x, then all of a sudden I have this function. It bounces off the x-axis, and I add all of them as if they're positive. By taking the absolute value, it just stays all positive. All right, that's all I have for us in the notes. Go ahead and write summaries.